So this video, it follows on from the last video we did, which was looking at how covalent bonds are formed. Just to recap quickly, a covalent bond is formed when two or more non-metal atoms join together to get a full outer shell of electrons. So what we're going to look at here is the properties of some of these covalent substances. Now we've got the title here, Simple Molecular Substances. The word molecule is used only to describe covalent substances. It's never used to describe ionic substances or metallic substances. It means covalently bonded, a particle with covalent bonds within it. So we're going to use methane, which is CH4, as the example here. And just to recap, just to remind you how the covalent bond works there, if we can do that. This is a recap of the last video that we did. Now, carbon has an atomic number of 6 and hydrogen has an atomic number of 1. That means there's 6 electrons around the outer shell, in the shells of electrons surrounding the nucleus. There's 2 electrons on the first shell and there'll be 4 on the second shell. That means carbon needs 4 electrons to fill its outer shell, which means it's going to form 4 covalent bonds because the number of electrons it needs to fill its outer shell is the number of covalent bonds it forms. Hydrogen has got an atomic number of 1, so it's got 1 proton in the nucleus and therefore 1 electron in the outer shell. It needs 2 electrons to fill its outer shell because that's the first shell. So we're going to have 4 hydrogens surrounding this carbon. And the covalent bond is a shared pair of electrons. That's the covalent bond, the shared pair of electrons. So the hydrogen shares its electron with the carbon and the carbon shares one of its electrons with the hydrogen. That's going to happen 4 times. And we drew these diagrams in the last video, so please recap on that if you can't remember or this doesn't make sense. There's a lot more explanation in that video about this. Okay, but that's what we have at the end. So that's what methane looks like when we drew it in the last video. Just check it's right. The carbon on its outer shell has now got 1, 2, 3, 4, 5, 6, 7, 8 electrons. Now when we started it only had 4, but by sharing these pairs of electrons, it's now got a full outer shell, and the hydrogens have got 2 electrons on their outer shell, so they are also happy. So that's what we drew last time. Now we're going to represent that slightly differently this time. We've represented it like this, where each of these lines is one of these shared pairs of electrons, these covalent bonds. Okay, and we're just doing like that to make it a little bit smaller so we can see how one molecule, this whole unit here is called a molecule. Okay, so I see how one of these molecules interacts with other molecules. Now, methane is North Sea gas. It's the gas that is used to power the gas fire in the gas cooker in your home. Quite like this. It's the gas that's used to fire the Bunsen burners in the science labs. And so because it's a gas, the molecules are not close together. They're far apart. So if we're going to draw what methane looks like, as a gas in this box here, if this box were full of methane, we'd draw a couple of methane molecules a long way apart from each other and completely random, because gas particles move around completely randomly. Okay, so what we have to do with all the different types of substances, ionic, covalent and metallic, is we have to be able to talk about their physical properties. By physical properties, we mean melting points and boiling points. Now, with ionic substances, they had high melting points because the oppositely charged ions were strongly attracted to one another. So the first question we have here is, do covalent substances like this have high melting points or boiling points? Now, we're going to probably talk boiling points, I suppose, because this is a gas at room temperature. Okay, so in this question here, do simple molecular substances like methane have high or low melting or boiling points? Then explain your answer. That says melting point there, but it's probably best to say boiling point. They go together. We're going to talk boiling points here because these are gases, and methane's boiling point is about -160 degrees centigrade, so really very low. So the melting and boiling points here are low. Okay, now this is a question that's asked by the examiner a lot. Why are the melting and boiling points for simple molecular substances low? Okay, now the answer that every student who gets it wrong, which is most of them, okay, because this question is mainly answered incorrectly in exams, the answer that students give is the melting and boiling points are low, and it sounds ever so good. Okay, the melting and boiling points are low because these covalent bonds are weak. That would make sense, wouldn't it? Okay, they're easy. If the covalent bonds are weak, they're easy to separate. Okay, and therefore they would take a little bit of energy to separate in terms of gas. And of course, that's complete rubbish. Complete rubbish, because these covalent bonds are, of course, strong. Okay, so what we have in here in these units, okay, are strong covalent bonds. So we can't say the covalent bonds are weak. But the students that write that, they're not completely daft, because of course it does sound good. So there must be something in their answer. And what in their answer is correct is there is something there that's weak, but it's not the covalent bond. The covalent bond is strong. Okay, and what is weak, however, is the attractive forces between the molecules. Okay, what we have between these are weak forces of attraction. Okay, between these molecules, there's nothing holding them together. I often, will give out a board pen when I'm teaching this to a student, ask them to break it in half. And I deliberately choose one of the plastic board pens that are impossible to break. And of course the student can't break them. Okay, but I then give the student another board pen. So they've got two pens next to each other. I ask them to separate the pens. Now they've failed completely to break the one board pen in half, okay, but it's perfectly possible to separate the two pens. And that's what we've got here. We've got a very strong unit, okay, but there's nothing holding these two units together. In the same way, there's no forces, there's very, very weak forces of attraction between these two pens. They're very easy to separate. So, because these molecules are not charged, they are not attracted to one another. Okay, so the melting and boiling points are low. Why? There are very weak forces of attraction, okay, between the molecules. Okay, there are very weak force of attraction between the molecules. Only a small amount of energy is needed to separate them. Okay, and that's the same for all simple molecular substances. All simple molecular substances have strong covalent bonds holding the molecule together, but only very weak forces of attraction between the molecules. Okay, are covalent bonds weak or strong? Remember, covalent bonds are strong, and we should never use this to explain why the melting points of simple molecular substances are low, or the boiling points are low. What is weak in the box showing methane above? Answer, forces of attraction. So all these two questions are doing here is just reinforcing what we've said above. Forces of attraction between the molecules. Okay, so we have to describe about melting points and boiling points for every type of bonding. We also have to just talk about electrical conductivity. So do simple molecular substances conduct electricity? Now we did this for ionic, and when we did it for ionic, the first thing we did to make sure we understood was to define what a current of electricity is. Now you cannot answer this question until you know what a current of electricity is. A current of electricity is a flow of charged particles. Okay, now there's two types of charged particles that we need to worry about. Either electrons or ions. Okay, now in this, explain if simple molecular substances are charged. All right, now simple molecular substances are not charged, no. Okay, they're not charged because unlike ionic substances, which were formed by giving and taking electrons, okay, now the electron is charged, so if you gain an electron, you gain a negative charge. If you lose an electron, you gain a positive charge. Molecular substances are not charged. Why? Because they are formed by sharing electrons. Okay, let's go back to our diagram here of methane. The carbon here okay, did not lose any of its electrons. Okay, they're all still there. The 4 crosses on the outer shell of carbon are all still there. Okay, it didn't gain, if you like, from the hydrogen either. Okay, it shared with the hydrogen. So it kind of gave the hydrogen 4 of its electrons, but it also received 4 electrons from the hydrogen. So this sharing, there's no movement of electrons. So there's no charged particles here. Okay, so there are no ions. Ions are in ionic bonding. So what's the current of electricity? It's a flow of ions. Well, there's no ions here because there's no charged particles. That's no ionic bonding. Explain if electrons are free to move in simple molecular substances. Answer no. Let's go back to this diagram here. All the electrons are used in bonding and held in place. Okay, no. There are no free electrons. They are all used in bonding. They are all used in bonding. So, do these simple molecules conduct electricity? There are no ions, there's no charged particles. We've answered that there. There's no charged particles, there's no ions. Okay, because they're formed by sharing electrons. There are no free electrons, there's no electrons that can move. Okay, because to have a current of electricity, we have to have free electrons, spare electrons, delocalized electrons that can move. There are none of those because they're all used in bonding. So are simple molecular substances good or poor conductors of electricity? Answer poor, because they have nothing that can carry the charge of electricity. There's nothing that means electricity can flow, a current can flow. And that's the properties of simple molecular substances.